Assalamualaikum. Myself Abdul Rafi, and I am here to explain the ultrasonic sensor. It is designed in the Proteus file, and we are using Arduino UNO to run all the system. So, starting with the Arduino, we are using the Arduino UNO. Here we have a LCD display 8 by 2. This is the ultrasonic sensor, and this is a potentiometer which we are using for the distance measuring. I'll explain that later. Now, from the LCD, we are using LM016L LCD, which is basically 8 cross 2 LCD. Uh, we are using this LCD so that we can obtain the results here. It acts like a monitor. So this RS pin is connected to the second of the Arduino, uh, which is the main pin. Uh, E is for the enable. The enable causes the LCD to glow. Uh, the VSS and RW pin are ground because we are giving power to the LCD using the Arduino, no other external current source. The D4, D5, D6, and D7 are the display lines that are connected to the Arduino board. Now, the Arduino is further connected to the ultrasonic sensor, the echo, and the trigger. The echo is the input that we are using, and the trigger is the output. We know the basic principle of ultrasonic sensor that one part sends the signal and the other parts receives it as it was reflected back from the surface. So the echo parts uh, send the signal, and the trigger parts collect the signal from reflected signal collects the reflected signal. The ground is ground, and we are using a power supply with a 5-volt DC supply that is connected with the uh, ultrasonic sensor. Now the connect it is connected to the ultrasonic sensor, but it we don't have like real distance imaging in the Proteus, so we are using a potentiometer. The 5-volt supply is also connected to the potentiometer. The potentiometer, as the resistance increasing, it tells the ultrasonic sensor that the distance is increasing and so on. So we can change the distance, um, uh, basically resistance, by this add and subtract. So this all is the ultrasonic sensor Proteus. This all is the Proteus circuit. Now moving toward the Arduino code, we are first, as usual, we are creating a library that is liquid crystal library, which is used to run the LCD display. Now the LCD display has its predefined pins, which are explained here. That 2 is the RS, 3 is the enable, and 4, 5, 6, 7 is the D4, D5, D6, and D7 pin of the LCD display. The trigger pin, as seen in the Proteus, is connected to the 12 of the Arduino, and echo pin is connected to the 11. We have created variables for duration, distance, and a float library for the liquid display. Now, we have the setup parameters here. It has the LCD pin up. There is a pin configuration pin mode, that is trig pin. That means trigger pin, which is the output pin, as I mentioned earlier, and the echo pin is the input pin. We have set the LCD cursor to 0, 0, and that distance is 0, 0. The and it displays the measurement LCD dot print. We have a delay 2000 here. That is all the starting of the LCD display. Now this LCD print is also the starting of the LCD display, nothing else. Uh, Here comes the main code where we have the word loop. The digital write means the trigger pins is initially low. That means it is not it is not having the reflected uh, wave. And at the second one, if the trigger pin is high, so here we have the delay microseconds. Same is the case with the echo pin. That echo pin is high. It as it always transmitting the signal. So here we have a distance centimeter. We have created the a formula for which it can uh, have the distance in centimeters. Like we are having a potentiometer and we have the values in resistance, so we uh, have the duration as resistance and multiply it with 0.034 and divided by 2, so we have the actual distance between the 2 points. And here comes the centimeter and all this. Now come to the main. Here we have the Arduino. We have to create the enter the hex file. Here we have there the ultrasonic sensor, and we have also programmed the ultrasonic sensor so that it can work properly according to our need. So we have entered all these. Now let's simulate it. Shows the initially programmed files are here. The LCD is starting and the ultrasonic is detecting any kind of change in this. So here it is at 26% and the distance is showing is 818 centimeter. Now if we change this, you see there's a change in the LCD display as the motion is changing. So here is all with my ultrasonic sensor. Thank you.